question 1.3 here. It says find the charges Q in terms of T flowing through a device if the current is A, B, C, and D. So it's important to know that we're giving the current, right, I of T, and it's being represented within a equation. So don't get panicked. We have to understand what we're being given and the concept that is related to this question. So over here it says we know from the book current is the differential of Q over the differential of T. So that means how many charges that passes through a specific point within a wire in 1 minute, right? The rate of flow of the charges in a wire. So this is just simple mathematics. In this case, we say, well, we have I, and we're trying to find Q. So in this case, we just times T and take the integral of it, right? And this would give us Q. Okay, so let's start with question A. So we would take the integral from 0 to T for the equation over here, which is 3A. And the answer should be pretty straightforward. It would be 3AT with T and 0. I'm just going to simplify it over here. I think you guys know how to solve this equation. In the end, it will give us 3AT. Now remember, we're giving the initial condition, and we know that this equals to Q of T, right? Because we're taking the integral, and this gives us Q, so this integral equals the Q of T, right? Now we say, well, okay, the initial condition is 0, so that gives us 1 coulomb. So say, okay, Q of 0. So let's type everything in. So this would give us 0, but we said the initial condition is 1C, so we know that we just plus 1C to the equation. So plus 1C, and that would give us the Q of T. And we can simplify it over here, of course, that A and C are the same thing, right? They're all ampere. So this would be 3T plus 1 in terms of C equals QT. Okay, go on to B now. Again, take the integral 2T plus 5. This should be pretty straightforward. We get, remember this is milliamp, right? This is the units here is milliamp. Just remember that. So this would be 2t squared divided by 2, cross that, plus 5t, right? This is the basic integral. I don't think I need to go into such detail. And T of 0, so this in the end gives us still this, gives us Q of T. Now remember the initial condition is Q of 0, so we plug 0 into here, and here in the end it still gives us 0, so that means it's good. There is no, and the initial condition, so there's no constant in here, right? So remember, usually if we take it to infinity, we usually plus the C here. We're trying to find out what that constant is. If you've taken ODE, Math 228, so like differential equations, then you know you deal with a lot with initial conditions. So there you go. We don't have to add anything. It's just this, and remember, we say milliamps or millicoulombs. Okay. Now, sorry, this should be C. We're no longer dealing with amperes. Should be coulombs. And this is number C here. So number C has a little bit of a challenge to it. And if you're in my class, I know this is this is our first homework. So let's go through this. So take the integral of this thing over here, 10t plus this, right? Micro ampere from 0 to t, and that is fantastic. Okay, Sorry, I just need to focus on this. Okay, so now we take the integral as well. For this one, it's not too hard. We're glad that t is only to the power of 1. So we think about, okay, what's the derivative? So what's the equation? We take the derivative, it gives us cosine. Well, sine, right? So we start with sine, and remember, everything within here always stays constant, right? And this is basic chain rule. And if we take the derivative of what's in here, it's just 10, right? We take the derivative of what's inside because this is the constant, this is gone, and 10t, take the derivative of 10t in terms of t is just 10. So obviously we've done enough integral to know that, okay, so if it's going to give us an extra 10, then we have to divide it by 10. And since there's already a 20 here, these cancels out, so it just be 2 times this entire thing over here with 10 and 0. And this time, let's just write it out because we know we're dealing with sines and cosines, and 0 doesn't necessarily give us 0 anymore. So here, everything stays constant, right? Plus this, and minus that, so 10t plus 0 now, that will give us 0. So it would just be sine of pi over 6, right? What is sine of pi over 6? It's sine of 30, which is a half. A half plus, of half times 2, that would just give us 1, right? And we are finished with the simplifications. This is just give us q of t. Now we have to deal with the initial condition that's giving us. So we plug 0 in. So we plug a 0 into this whole thing. So this would be 2. We actually don't have to, I guess, do anything. Oh, sorry, remember the units is micro ampere. And so 0, we plug a 0 in. This would be 0 half. 0 here. 10 times 0 equals 0. So sine of pi over 6 give us half. Half times 2 equals 1. 1 minus 1 is 0. So great. We just have to plus this whole thing. Cosine of t. That's 10. 10t plus pi over 6 and minus 1 and plus 2, right? Because this micros column has already been simplified to here, right? So now we just have a 2 over here, and we simplify these two, it will just becomes plus 1 instead equals q of t. And we simplify in the end. Remember this whole thing, it's still times macro c. And in the end, so it would be macro c times 2 sine of 10t plus pi over 6 plus 1. And that whole thing what gives us q of t. Okay, it's a little different than what Czech presented, because they just said, okay, you just plug q of t. Obviously, it's okay because you're lucky enough that everything keeps giving you 0, right? Like over here, it still gives you 0 in the end. But we showed the mathematical way of if you have a initial condition, this would be the safest and the most fundamental way of doing is you plug in the initial condition and find out the constant and then add the constant in, right? Okay, and the fourth one. The fourth one, it is a little, well, not a little, very pain in the butthole, because there is a lot of, it's very integral, calculus heavy question. Sorry, hopefully your professor didn't give you this as your homework. But you have me if you do. If you do, you have me, and I'm here to solve it for you, to explain it. Okay, so in the beginning, we still take the integral of 10 times e to the power of negative 30 times and times sine of 40t ampere, right? I believe this a times the entire, no, just that. Okay. Fantastic. All right. Well, a is a constant. We can just move that out. So, okay, erase this. Oops, sorry. So you guys know we moved the a out, and we also can move the 10 out, right? And 10a over here. Fantastic. And this is the equation that we have to deal with. Now, this we have to use integration by parts. Usually when you have two of these and you take the derivative of one, it doesn't cancel the other one. It basically is integration by parts, and it's mostly that. There's not really much trig heavy. There's E over here. There's two forms of calculus. Two different forms of equations, and I think you've been through Calc 3 or Calc 2 by now. If you've been through Calc 2, then you should be pretty familiar with this. So, integration by parts. U, du, and what do we pick for u? We pick sine of 40t. So du is 40 cosine 40t. And what do we pick dv? dv is e to the power of negative 30t, so v is e to the power of negative 30t over negative 30. And then what is the differential by parts? U times v minus v du, right? This is the form. So we just plug everything in now. So sine of 40t times times v, so e to the power of negative 30t over negative 30 minus, and here we go, let's write everything again, and this is du, so du is 40 cosine of 40t, and okay, and du, times v, which is e to the power of negative 30t, and negative 30. Okay. Oof. Now, same format. Let's do the integration by parts for this thing again. So what do we pick for u? U, we pick 40. Oops. Wait, give me a sec. Is that correct? Yes, it is. Okay. Fantastic. So 40 cosine 40t, and u and du is 1600 sine of 40t. And what is dv? dv is this thing. We pick that as dv, which is e to the power of negative 30t over negative 30. And so v will give us e to the power of negative 30t 900, right? 30 times 30 equals 900. And let's plug everything and do it again. So we're just gonna write, well, you know what, for the formality, let's just copy the whole thing down. 30t, negative sign over here, not over here, this is times, negative 30 minus, so u times v, so that would be 40 cosine of 40t times, what's v? 900, right? E to the power of negative 30t, and then we say take the derivative, and that is 6 du, so 1600 sine of 40t divided by, oh my gosh, we're almost there, and divided by v, right? So which is 900, oops, sorry, 900, not 9,000, and e to the power of negative 30t. Okay, fantastic. Now we can simplify. Well, we can definitely simplify this, right? So 0, 0, and we take the 16 and the 19 out. I think you guys can see that, right? So we take the 900, oops, we take the 900 and the, this is a negative sign, so let's not erase that. And we take it out over here, 16, 9, right? And and realize, well, my gosh, are we gonna keep going like forever? Because this is just what we started with, right? The sine of 40t times e to the power of negative 30 times t. This is exactly what we have over here. Well, that is a good news, ladies and gentlemen, because this entire equation, what does that equals? It equals this equation, right? Even though there's tons of calculus, we can just deal with this as an algebra, right? Because this form, the integral of this entire thing, we can just treat it, I don't know, a symbol, a triangle, a heart, or a star, whatever you name it. Well, that's the terrible star. There we go. And then we treat this as 16 plus 16 over 9. 16 over 9 plus r, right? And this is 900. Sorry, there's no negative signs over here. So we can just treat this as like we added all the way over here, right? We just, we just added over here to this side, right? We add 16, 9, and the blah, 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 which gives us 16 over 9 plus, this is 1, so 9 over 9. That would give us 25 over 9 times the integral of e to the power of negative 30t times sine of 40t on this side of the equation, right? And this is the answer that we're trying to find out. And there is a constant in front of the answer, so let's times 9 over 25 on both sides of the equation to get rid of this. And so this two equations over here is going to times 9 over 25. 9 over 25. Okay, so here's negative 30, right? So negative 30, we cross divided by 3 by both sides, so negative 10. And this would be 3 times sine of 40t times e to the power of negative 30t over 25 times negative 10, negative 250. Minus, here's 40 and 900. So we simplify this equation first, which gives us, which gives us 4 over 90, right? And cosine of 40 t times e to the power of negative 30t. So, and that times 9 over 12, right? So 4 over 90 times 9 over 25. We have to simplify that somehow. So good, 9 and 90 would just be 10, and 10 times 25 will still be 250. And the number on top, which now it's just 1 because 9 and 90 simplified, and 1 times 4, which is right exactly what's on top here, times e to the power of 30t. Perfect. And this is canceled. And so this answer equals this. Now, we're not finished because remember we shift the 10 out, right? Now we have to say, well, each side times 10. Okay. Now both sides of the equation times 10. And this side times 10, right? This entire thing times 10. What does that give us? Well, we just get rid of 1, 0, right? And obviously we also times the c, right? This is the a over here, the beginning part, which is c over here. Excuse me. And we'll get rid of the 0 on the bottom from the 0 over here, and the c. So we can do some like simplifications going on, going here. So e to the power of negative 30t over 25 negative times c, and this whole thing would gives us 3 sine of 40t minus 4 cosine of 40t. And I'm glad e to the power of 0, 0. We plug 0 in here. It would give us 0. Well, it doesn't matter what, because wait, do I have to add anything to it? This is a little, well, okay. It's the initial, the initial value is 0. It doesn't matter what it is, it's still 0. Fantastic. Okay. And this would be it. On check, they simplified the number, but this is still also the right equation. You can obviously plug your number in and simplify it if you want, like 3/25. You can calculate that. And but yeah, I think this is everything for question 1.3. So the first, second, and third one is not okay. It's a doable, and the fourth one, if your professor give it to you, he is just pure evil. But anyway, hopefully this video helped, and I'll see you in my future videos. Bye.